Okay, welcome back to Chapter 4, Part 2, Introduction to Probability. We're going to move on down here. This is where we left off. So we're talking about combinations and permutations. You can see n factorial over little n factorial times big N factorial minus little n factorial. For combinations, order does not count. For permutations, order is important. Big N factorial divided by big N minus little n factorial. You're going to have more permutations than combinations because here order doesn't matter. Here it does. Assigning probabilities, basic requirements for assigning probabilities. The probability of any event, E sub I, say a 6 coming up on a dice roll, has to be greater than or equal to 0. There are no negative probabilities, and it must be less than or equal to 1. 1 means it's absolutely certain. There's nothing more probable than that. E sub I is the ith experimental outcome, where the probability of E sub I is its probability. So if we had here, we'd have the probability of, say, a 1 coming up on a dice roll. E sub I would be experimental outcome I, in this case, 1. The probability of E sub 1, the probability that a 1 comes up, would be 1 over 6. The same thing for a 2, a 3, a 4, a 5, a 6. If we added those all up, they'd add up exactly to 1. E sub I equals 1 through 6. Okay, the sum of the probabilities of all experimental outcomes must equal 1. The probability of a 1 plus a 2 plus a 3 plus a 4 plus a 5 plus a 6 for a dice roll, 1 over 6 added to itself, 1 over 6, 1 over 6, 1 over 6, 1 over 6, 6 times would be exactly equal to 1. N is the number of experimental outcomes. When we assign probabilities, there's 3 different methods. There's the classical method. Here we assign probabilities based on the assumption of equally likely outcomes. Examples of classical method when assigning probabilities are the flip of a coin. The probability of a heads is exactly equal to the probability of a tails. Those are the only 2 outcomes, 0.5 and 0.5, and they add up to 1. Another example, the dice roll. The probability of rolling any number on a dice with a fair dice on one roll is 1 over 6. The next thing we have is relative frequency method. This is also called empirical probability. Here, we're assigning probabilities based on experimentation or historical data. Insurance is an example of an industry that uses this relative frequency method or empirical probability. We might look at, say, New Orleans, and we have maybe 500 years, believe it or not, worth of data on hurricanes hitting New Orleans. And we might say over the past 500 years, 50 hurricanes have hit New Orleans. So we have 50 hurricanes divided by 500 years. The relative frequency method would tell us that the probability of a hurricane hitting New Orleans in any given year is 50 over 500, 1 over 10. And then we have the subjective method. You see a lot of this in sports books, okay, when they set probabilities that, say, the Patriots will win the Super Bowl. They then use those probabilities to assign odds, which you bet on. So that's the subjective method. You're just sort of using information that's present to you and forming a judgment on what the probability is, okay? Very certain. Pretty certain, pretty uncertain. Here's the relative frequency method using Lucas tool rental. Each probability assignment is given by dividing the frequency, the number of days, by the total frequency, which is the total number of days. So you can see here, number of polishers rented. 0 polishers were rented on 4 days out of it looks like 40-day period. 1 polisher was rented in a day on 6 days, and so forth and so on. So here, if we want to know the probability using the relative frequency method that 0 polishers will be rented today, we'll take the number of days that 0 polishers were rented during our 40-day period, 4, and we'll divide that by the total number of days we used, 40, just like I did with the hurricanes. 50 hurricanes over 500 years. Here, the probability that 0 polishers are rented is 0.1 or 10%. Remember, if you take a decimal, multiply it by 100%, that'll give you the percentage. 0.1 times 100% is 10%. The probability that 1 polisher will be rented is the number of days that 1 polisher was rented, 6, divided by the total number of days, the total frequency, 40. 6 over 40 is 0.15. 18 over 40, 0.45. There's a 0.45 probability or a 45% probability that 2 polishers will be rented, so forth and so on. When you're done, you want to check your probabilities. Make sure all of your possible outcomes are listed here and that their probabilities add up to 1. If they don't, you either made a rounding error here, okay, or if it's close to 1, then it could be rounding error. You made a math mistake here, it doesn't add up to 1, or you don't have all of the possible events that could occur. Events and their probabilities. An event is a collection of sample points. The probability of any event is equal to the sum of the probabilities of the sample points in the event. So here, let's say you're picking M&Ms out of a bag, and you're going to pick 2 M&Ms. Say you pick a blue and a green one. That is a sample point. Now, the probability of any event would be the probability of, say, picking a green M&M out of the bag times the probability of picking a blue M&M out of the bag. Let's say there are 10 M&Ms in the bag. 3 of them are green, 4 of them are blue. The probability of picking a green M&M is 0.3 times the probability of picking a blue M&M, which was 0.4. 0.3 times 0.4 would be equal to 0.12 or 12%. We'd say there's a 0.12 probability or 12% probability that you pick a blue and a green M&M out of the bag. If we can identify all the sample points of an experiment and assign a probability to each, we can compute the probability of an event. Here we have the example of Bradley Investments. M is the event Markley oil is profitable. You can see here it could make 10 and 8, 10 and negative 2. If you remember from before, 5 and 8, 5 and negative 2. So there are 4 possible events where Markley oil could be profitable. Then we have events where Markley oil is profitable here, and we're going to add those probabilities. Each one of these probabilities, 0.2, 0.08, 0.16 plus 0.26. We were given those on a chart that I didn't include here. We can add those probabilities together and figure out the probability that Markley oil will be profitable in the future if these probabilities up here were correct. And in this case, you sum these probabilities, the 4 profitable Markley oil events, and you get a 70% probability that in the future we'll have one of these events where Markley oil was profitable. Some basic relationships of probability. You'll remember some of these from math. These can be used to calculate the probability of an event without knowledge of all the sample point probabilities. We have the complement of an event, the union of two events, the intersection of two events, and mutually exclusive events. The complement of an event, is the probability that an event doesn't occur. So if we go back here to Markley Oil, there's a 70% probability that Markley Oil is profitable. Markley Oil could be profitable or not profitable. The probability that Markley Oil is profitable or not profitable is 1. We subtract out 0.7, and we can find out that the complement that Markley Oil is not profitable is 1 minus 0.7, or 0.3. We will continue with the rest of these on the next video. Thank you for watching. Watch the next video. Thank you.